Hi, Graham from Cold Tool Centre. Today we're going to give you a run through on how we set up our machines from the time we open the boxes when they arrive in the country to the time we close them again after being checked, tested and calibrated, ready to be sent out to the customer. These are the tools and the components that we use to upgrade our machines to have information like our identification. So that's an identification card. These are the warning and that sort of stuff that we put onto the machines. This is the CD we supply, which is the setup CD and readme first file. Testing material for testing the lenses and the mirrors, which is basically, I'm using masking tape in this case, a ruler for checking the height, set of small spanners for undoing your nuts and locking nuts on all your mirrors, etc. Some 9mm spacers for this particular machine, which is for the focal length check. Some glue to glue our stickers on. Some double-sided tape to do our labels on. An O-ring which we put under the lens to stop it from moving and getting damaged by the metal-to-metal setup. Screwdriver. We put some English labels on there to make sure that everybody knows what in, out, door close, pumps on, up and down. We add a extra connector which goes on the earth outlet, because in the China etc they have proper earth spikes in the building. In Australia we use an earth pin on our plug. We also have a square for checking square. That's the sort of equipment you're going to need, plus you need to open your box. That's the box there, so we need a hammer, maybe a chisel to open the box so we can get into our machine. Once you've opened it, you need your bucket of water and you need Corel Draw setup. Okay, we have the machine out of the box there now on the bench. Using the supplied keys, we'll just remove these doors. This front one. And of course we have one on the side where all the main controls etc are. Put these aside. We've already pulled out of the box is our water pump and an air pump. This is our water pump and our air pump. So we'll both pull these out of the packaging. These use an American plug, which is fine because we're on the back of the machine. We have a rail or a strip system which we can plug this into, which is fine. From here we can cut our packaging open for this part. We have, each machine has 4 rubber feet which stick into the bottom of the bottom, and we have a brass fitting which goes in here. Thread tape on this, a fair bit of thread tape on it. This is our outlet of the water pump, which goes to the inlet of the machine. Thread tape in there and put that into the fitting. Put the feet on. We save the plastic, we save the ties for when we put it back in the box and repackage. This is the air pump. Carefully open all this. In our packaging we should be able to find the outlet, which is a little brass outlet like that. Just use our thread tape on that as well. Okay, so we just nip this one up. Okay, the machines usually come with a ground wire because in China, etc., they have an outlet on the wall and they plug that straight into the ground. Here we're using the earth wire on that. It's already hooked up to that. But what I'd like to do is make sure that the chassis is also hooked up from the back of this bolt to the earth as well. So I normally just split the wire, wind it up, put that one in that. Let's go inside here. As you can see, it's far enough in to get caught. Go to our blue fitting. Crimp. Now we just basically put that back through the hole, and on the inside of one of these screws under the nut, we just place under the nut. Then we'll do a multimeter check between the chassis, somewhere like that, and there, to make sure it actually is going to that pin. These are the small strip switches on the back which are going to hook up for our water pump and an air pump, which are controlled from the front. They're not brilliant quality, so basically I normally pull them apart and make them work a bit more efficiently. What seems to work better is we bend that up like that and tweak that back down. So we're bending this so it's coming in harder, then tweak it back down so they can get into it. So that seems to make them a bit more secure. Right, once we hook our wire up, we can then test between there and there. Okay, that's a good circuit. Now I basically will test from up here somewhere, anywhere else on the machine, to earth. We've got a good earth. The whole machine is earth to the earth pin. We will label these in a minute, but this is the water inlet, this is the water outlet, air inlet. So basically on the water inlet, we're hooking up to our water pump. So that's your inlet. That's the outlet of the water pump, goes to the inlet. It depends. Most of the time, sometimes these are nice and firm, which is good. Other times we have to put a cable tie on. So I normally supply a cable tie just to make sure that this doesn't pop off. Okay, we have our bucket down the bottom. Oop. Okay, we have our water bucket under the counter here. So we basically just drop our pump into the water, let it sink, straighten our lead out a little bit, make sure we do our return hose back into the water, otherwise you'll have a big wet mess. And we're going to use the strip sockets on the back here, which I've modified. So they're quite firm to get in now, which is what you want. As far as the air goes, same thing. Air tube on. This is not usually a problem falling off here. It's just usually straightforward. Straighten our tube out. Run it to our second strip. Nice and firm. Okay, so that's basically our connections there. I will label these in a minute. This is our bag that comes in their packaging. Basically what we have: USB cable, power cable, software, which is Corel laser draw, Corel laser, a sample piece of 9mm, which is the thickness of our focus, our USB dongle, and a spare switch. This is just a bit of a strip for our hose, concertina hose for the outlet. This is what they supply from the factory to check your mirrors, etc. with. Right, these are our warning labels. This is danger inside, so this cover here covers over there, so it goes on the outside of here. The other one basically goes on the front, up the top there, and our normal identification card is going to go there. So these couple here, I will put some glue on there and they can dry off a little bit while I'm doing other jobs, and then I just poke them onto where they got to go. Just a warning that, you know, like, a lot of stuff's common sense, but we have to make sure we cover our common sense these days. And this fella, I basically just use a bit of double-sided tape. ID tag. The indicator on here is, it's a GY5430 50-watt machine. About 6 months 2020 it came in. 61 machines we've sold. Label goes in here. Double-sided tape. Beautiful. While our glue's going off, we will undo our USB cables, etc. Keep all these neat so we can repackage them to go up to the customer. Wipe our surface, align our danger voltage inside. We can clean that up after. And our main cabinet here, we will put this one. Line it fairly close to the middle. Cool. While we're still tidying up here, we will then, this is the water in, out. This one tells you to have the doors closed and the pumps on. And these last two are the table switches, up and down. So I'll just affix them to all the relevant places. That's the effect we're having there. Doors closed. This is our main power control panel, and power to the actual head itself for movement. And this is the laser radiation class 4 labels. Down the bottom here we have the light switch, strip switch, main switch, and a lift switch is up and down. So we'll put up and down on that one now. Up, down, lift switch. USB installation. So we can put our USB cable into there. We plugged our 240 volt cable in. In and out for our water. That's your inlet outlets. We have our compressor already, our computer already hooked up. Our USB cable, our USB dongle goes in, and our USB cable goes in. Inside our cabinet here, we have a length of tubing which is going to be used for ducting. Okay, this is the main switch. Second strip is a strip switch, which means the power to the back, which is the pumps and the air. When I turn that on, you'll hear the pumps, water and air pump start. That noise is the pump vibrating against the chassis. So now that's the sort of noise you get, quite quiet. This is the switch for the internal lighting inside there. When we turn on our switch here, the machine will home in the X and the Y axis. If it was out here, you'll see it do it. Okay, off she goes. X and Y axis, she's zeroed. One of the few parts of the machine that we don't test is for a honeycomb table. I use my own honeycomb table, and I have a bit of aluminium in there so if it burns through a hole or whatever, it doesn't mark the new machines. So basically I just line that all up. Now, everything's on except for the laser. Now the key switch turns the laser on. It's not working unless the key switch is on. Of course, the doors have to be closed, the pumps have to be working for it to actually engage. So once we get to about here, we can run our Corel laser, and it'll ask you wanted to multiply stuff on the hard drive. Of course we do. We have our dongle set up. It's going to look for the dongle, or the key as it calls it, and then it's going to try and find the machine. Okay, this is now looking at Corel Draw. It opens Corel Draw because Corel Laser is a plug-in for Corel Draw. Okay, our control panel for our lasers up here. The rest is just basic Corel Draw. So we are going to find our some of our test stuff. Open recent. So a 15mm square is one of the first things we cut. Probably going to cut it at 6mm a second. It's already offset 135 by 5. If that's too far out, let's bring that back into about 80. Let's bring that back into about 60. So what those adjustments do is move our cutter head around the table. So it's no longer on the 0 and then it's down that far. So we've positioned where we want to do our cut. So we basically just check that we have our right focal length there, which in this machine is 9mm. Now we turn on our laser and a display comes up. We're going to cut this at 6mm a second, 3mm, let's go 30% power. I think that should be enough. Basically, going to hit go, and it should cut that. The reason it's cutting with the lid open is I bypassed the switch. Not something recommended, it's only used for basic setup. Okay, so that drops out, that's cut correctly. Once our little square has been cut, I use mark it, so I know how it's orientated. And then basically I use my square with the background there. Okay, it's good that way, it's good that way. So I'm happy that at the moment that is cutting square, so that means that everything's straight on the bed. Now we're just going to do a check all our stuff is working where it's supposed to be. So I'm going to reduce the power down to about 10%. I'm going to get a bit of my tape. I'm going to place a bit of tape on the opening here. Push my machine right back to the closest to the laser, because your laser first mirror is on the laser is there. I'm going to give it a short test and you'll see it'll just mark. So that's where it's just marked there. So the next thing is to bring it right to the far end and test it again. Now that's on top of the other, so that means over that complete distance it is parallel, so that's fine. If that was not fine, I would walk that second lamp into be on top of the first one with the adjustments on the first mirror. So now I usually just check it in the middle. If you want to get excited, you can start checking outside. If you check in the middle, it should be okay unless your bed is not square. So now we're going to be checking the second mirror. Okay, so I'll still use the same stuff. So we give it a slight test. There. Bring it to the full extent. As you can see, it's got the mark. It's usually above the center a little bit, a mil or two above the center, which is nice. That's where you want it going, and we want it, okay, that's probably down a little bit, and this side. So we've got to try and move it up in that direction, up and to the left. So we'll just do a slight adjustment on this just to get that a little bit better. I can see an issue with here already. The guys, when they do it from the factory, everything is clamped down there. So there's, you know, it's held in with these springs which push the mirror, so that should have some freedom in there to pull it, but they've got it that tight that that's just solid. So there's no adjustment. So we basically have to loosen these Allen keys off for a start before we can do anything with it. And they're basically just spring loaded. So because everything's bottomed out, we can't really do any adjustments. So the first thing I'm going to do is bring it all out so that I can do some adjustment. So these are 5mm on these, 5mm, 5mm, and 5mm on the lock nuts. So they're all lock nuts to sort of try and stop the machine, stop it coming loose, etc. This last one is always a bugger. Okay, so what we're going to do, I'm just going to move all of these. Oh, that one's still a bit tight. Move them all out to get some clearance. We have no clearance there at all. And this is the thing, if they set up like that, you can't adjust it because there's no way to adjust it because you're bottomed out. So, okay, so I can see that one's moved out about 1 mil or so. That one's moved out about 1 mil or so. And that one's out about 1 mil or so. Now that's changed everything, of course. Everything's, because you know, like everything is now not going to line up. So I basically have to do my first test again because that's just changed the whole thing. So we'll test that. Okay, as we can see now, it's over to the left and down. So if it's over to the left and down, that's what we've got. We have to move it up. So if we push these two bottom ones, we'll move it up, and if we want to push it across to the right, the one over this side, the back, will push it to the right. So basically we're going to move it up with these ones, but these are very small movements, like 1/4 of a turn, and this back one we're going to go a bit more because we want it to go up as well. So basically we've got it across a bit. Probably could still come across a little bit more. And still come up a little bit more, I think, as well. Now we can either keep coming up on these ones or drop this one down a bit. We're starting to get too messy now. Let's start again. So test. Okay, so that's pretty well where we want it on those mirrors. We'll do a secondary test here. Okay, you can see it's way over to the right and it's high, so it has to come down and it's got to come across to the left. So that means if I wind these two across, that will move it in that direction. If I tighten them, if I loosen the one on the other side, that will do the same thing. It'll make it go in more at the back. So I'm going to loosen that one a little bit, and I want to go down a bit, so I'm going to tighten that one a touch. We'll test it. We see we've nearly got it there already. So we still got to go a little bit more to the left, and we have to go down. Okay, we're getting close, so we've still got to go across to the left. That's probably getting close. Now, all this time I haven't locked up any of the nuts of that because we're playing with it. We're trying to get it in the paddock. I think we're getting close, so now I'm going to tighten my lock nuts up. Because this will change it. When you're tightening lock nuts up, everything wants to move again. So you've got to make sure that you check it with the lock nuts nipped up. Once we get it right, it should be in the middle, or pretty close to the middle. Up a little tiny touch, and the secondary one should be on top, which is good. So the last alignment one was usually go to about the middle. Find myself a piece of board to try. I usually put a piece of masking tape across there so I can actually see. So basically we're going to do a test there. We then hold that down so it doesn't move. Then we use the corner edge of our square to see where it is relative to the centre of the nozzle, which is good, in the centre. And we look at it from the other direction as well. It's not dead centre, but it's pretty good. The next modification we make, we pull the lens out, which is inside the tube. So we pull a rubber hose off the back and see if it'll move. Usually, yeah, oh there we go. Okay, so we've got that. Okay, most of the time when I receive them, I believe the lens is upside down. I believe the convex area should be to the top and the flat should be the bottom, so they supply them from the factory the wrong way around, I think. So I changed that. Now, as you can see, there's a bit of carbon and rubbish inside there, and we've got metal to metal. So first thing we do is undo it. Basically we just loosen that up. I use something like that to pull it all the way out. There's carbon and rubbish on top of that, inside and outside. Alcohol or methylated spirits in Australia, give it a clean. Now you can see that's the convex. We're going to put that up and the flat to the bottom. So put it in, that's gone in nicely. Now to stop it getting damaged, I get an O-ring and I use the O-ring like that, push it in all the way around. Now what happens when the nut comes down onto that, it holds it firmly, but it also stops it getting damaged by the metal to metal, and it won't loosen up because the rubber becomes like a spring washer. So we put our nut back in now, finish tightening it up, the machine, tighten it up, thread the nozzle back onto the housing. Won't quite line up anymore now because the O-rings put it down a little bit more, so you just basically bring that down, bring your lock nuts down to get it, get your air hose, air feed. Okay, so the next thing we're going to do is check the bed. I'm basically just going to check it in 4 corners and measure the distance between the nozzle and the end. So I'm coming in through the front. So we're just going to measure the distance, which is about 35 millimeters. Move it to the next corner. It's probably a little bit less, so that's probably up a little bit in this corner. 34, say. Definitely up in that corner. About 35. Okay, we've run our ruler over the 4 corners. We're a bit higher on this side than the other side. In the past, there's little lock nuts and everything in there, which are very difficult to be able to shift. The easiest way to do this, because it's only very thin material, plate material, is you're basically pushing it down. So this one's up about 1 mil here and here. So both of those compared to this side. So this side's up a little bit, and as you can see, there's a little bit of movement to all this stuff anyway. So now we have the table set up correctly in all the 4 corners. Now another thing we always check but they go all the way down and all the way up. But what I'll do, I'm going to go down because the way they put the heads together, I modify the stop. So we'll take it. So we'll take the platform all the way down now. When the platform gets to the bottom of the travel, it has a switch there, a big switch there that turns it off, and it should stop going down, and then you should be able to bring it back up again. It's coming towards the switch now. Okay, she's turned off. It won't go down anymore, but if I bring it back up, it'll come up. While I'm doing this, I'm going to leave that there at the moment. I'm going to pull this top switch off. I take the roller off here because that just looks stupid. We cut that piece off the roller, and also I'll show you we actually put a insulation instead of just stick tape around the top one to make sure it can't short out on the chassis anywhere. Turning it all off. So we're pulling these bolts out, and this is our switch. Everything's turned off at the moment. This is our switch. Now you see they have insulation on there. Make sure that there's no screw in there, because what can happen if it goes up too high, it can actually short out on the chassis, because that becomes live if either of these when it becomes into the off position. So basically I'll take these off. I'll just grind this up and I'll show you what it looks like when it's finished. Okay, so we've removed the roller, straightened the arm out. That arm comes down and will sit on that, and that's what turns it on and off. We put our two screws back on. Put our two screws on, but what I do then is put a bit of double-sided tape onto there so it makes sure that that's insulating all that away from anything on top that it might be able to hook up to and cause a short of any description. Okay, after we've completed the modification, that's what this will look like. Fitting back up. So once we have set up our switch and that, we're basically just going to bring it right up with the table in it and make sure that the switch turns off, but make sure we do get so we can put paper or that sort of very thin material, and we can still get the focus in there. If it doesn't, we just have to bend the end of the touch where it touches and get it correct. Now the next thing we'll do, we'll just cut a 15mm square in our about 6mm thick material. So because we've been changing all the locations and everything, we now have to set our height. We can scroll the head around the surface and set it up wherever there's a spot we need it here. So I've say that you move that across in one axis and down, and you can move that from your software. So once you've got it where you want it on your page, you set your focus. You've 9mm this one. Okay, that's clear, lovely. Now probably run about 40% power. Okay, so it should cut our square. If it's cut right out, it should drop out, which it did. Then we just mark it to make sure we've got it the right way up. Lift our piece off. Now, I just eyeball this, but what you can do, I'm just looking to see if both sides are nearly parallel. That's very good that way. Probably slightly out that way. Nearly square. You can't get it perfect, but that's very good. If it was out a little bit one way or the other, you can actually move this head. You can put spacers, etc. under it. You can move that head by putting some base on that side, move it in that way, and that should change the angle of your cut. You know, you can bend the little tag here a tiny little bit if it's a little bit out. One of the last things we do is do some test pieces. Now these test pieces have circles, squares, cuts, engraving. We are basically running the machine through its paces. It all should look uniform, circles should be round, should be no jumping, etc. This is the final test before we start cleaning the machine up and packing it ready to send away. So first thing we're going to do is engrave a component. So it's going to be engraved at 25% power at 250 millimetre a second. This first sheet here will also have these indications of this piece was cut, engraved and marked using the settings that's going to be on this first piece up the top. So basically it's engraving the section of the piece which is engraved, and as it says, engraving it at 25% power, 250 millimetres a second. While that is finishing, we can go over and modify it to a marking, which is the next process. The only thing we can't change yet, of course, is the power, which we changed manually on our board. So we can go over, get set up. So we tell it we wanted to print the marking, we don't want to print the engraving, and we don't want to print the cut. So while that's still working, we can actually hit the marking. So the marking, as we said, it's going to be 15% power at 20 millimetres a second for this test pieces. Okay, we're going to hit that, starting. Now, marking is basically the same as cutting, except it's going faster and a different power setting. As you can see, it says marking at P15, power 15. We're going to be cutting at power 45. And this is a 50-watt test. See, we're doing lots of different shapes, circles, squares, triangles, and all this should look right. If it doesn't look right, we know we have to go back and look at something where we have a problem. These are all very fine things, and if they don't look right, there's an issue. If this circle had different layers and it was all out of shape, and that, we would have problems with belts or other issues. But it's all looking good, and while that was happening, we could have been jetting the next setup, which is our cutting. So to cut, we're telling it we want it to cut. We want to print the cutting, we don't want to print the marking, we don't want to print the engraving. So we hit the cutting, and that one is going to be 6 millimetres, so we change our speed to 6. And we're going to go 45% power. Now we hit that, start, and there it goes. Now, as you can see, that's cutting through correctly because that piece fell out. So if it's falling out, it's cutting through all the way and there's no little gap. Now and again you'll get a little pieces that will hang on. You may have to sort of clean up with a little scalpel or something. Usually you're going just a slightly bit fast, or it's maybe hit something, bounced off something on the back of the honeycomb tray or something like that, which has caused it to fail to cut all the way through. But usually, see that drop then? So that's dropping out. Now all these pieces, one of these pieces will go onto the key ring, which comes with all the keys and a test piece, etc. That gives you an indication that this machine of yours at these settings did all this information and cut exactly what is in here, front of here. So it's capable. On the day that we tested, this is the final test that we do. So all that's correct. I will now pull that out. I put a bit of tape on the back of this and pull this masking off here. And that gives us a finished piece with all that nice cuts and a nice unsmoky surface. That just comes off all of those around there. Once we've completed the last test, we have these 3 pieces. This one is indicating at what power and speed each of those actions we use. So engraving 25%, 250, 15% power, 20 millimeters a second, cutting at 45 at 6 to cut that 6 millimeter MDF. This one's just giving us a very good indication of lines, everything's square, nothing's out of round, the belts aren't slipping, the belts are fine, all that sort of stuff. These two do that. This information pack has your starting software and that sort of stuff in it. This is the software, the Corel Laser. The information pack is used to set up your machine. So there's a lot of information on there which I supply. You can go through that and it'll have a README first folder, read all the information and follow that. You should have no issues setting up your machine. These are your keys. You've got 4 of the that key plus 1 for the main laser. And these are your 9mm focus test pieces. So this will all come inside your bag. We now basically enable our switch, pull all these pieces off, vacuum and clean the machine, put all the pieces inside and repack the whole machine. Ready to go.